Hi everyone. So today we're looking at Lab 3, finding the mass of a black hole. So let's just start with what we already know. Our system is a star. We have the star's mass, the time step, which is 1 Earth day. We have a universal gravitational constant. And what we need to find is the black hole's mass. So in order to do this, we'll be using the fundamental principle of Newton's universal law of gravitation. As you can see here, we'll need the gravitational constant, the mass of the star, the mass of the black hole, which we don't know yet, and also distance. So we'll find that F net equals this value after we go through a Python file. So as you can see, we have accounted for the black hole in this computational model so that it'll appear when we run the model. We inserted the mass of the star, the black hole's position, the time step. We also had to account for the x and y component of the velocity. We're also starting at where time equals 0 seconds. We edited for the position, initial and final. And then finally, towards the end here, you'll see the black hole mass is just basically a rearrangement of Newton's universal law of gravitation. So we rearrange the equation so that the mass of the black hole equals magnitude of F net times magnitude of distance squared divided by the gravitational constant times the mass of the star. So then we'll just run this model, and it'll say the mass of the black hole is for every single second that's passing by. So as you can see, the star has finished its orbit in the model around the black hole. And if we look, we can see that we have the mass of the black hole and what F net is. So basically the computational model accounted for the F net force and then used that to find the mass of the black hole. And in this case, F net is due to a single force, the gravitational pull of the black hole. We're not accounting for any other forces right now. So the mass of the black hole is 1.98 times 10 to the 31st kilograms. So what does it mean in terms of F net perpendicular, F net parallel, and just regular F net, the vectors? How are they different from the change in momentum over change in time, parallel, perpendicular, etc.? Well, there isn't really a main difference. The only thing that I could say that's different about them is that F net is more of a concrete calculation, while the change in momentum over the change of time might be more of an approximation. Because looking back at this star data, which is used in the computational model, the change in momentum over change in time is basically just having a velocity of every two consecutive x and y position coordinates. So it'll be the velocity of these first two positions, and then of 2 and 3, of 3 and 4, just taking the velocity of that. So there's not really that much of a difference because the data in this scenario is just so specific. But in general, the main difference is that the change in momentum over change in time is more of an approximation, if anything. And for the what if question, if a black hole was replaced by a different black hole and the only force acting on it was still just the gravitational force, the orbit of the star was the same, then there wouldn't really be a way to tell a difference unless there was a different, more than the gravitational force acting upon it. So there's not really a way to tell a difference unless the star's orbit was changed or something of that nature.